Objective: to write the electronic configuration of carbon and phosphorus and understand the condensed method of writing the electronic configuration of elements with greater atomic numbers. Electronic configuration of carbon. Let us write the electronic configuration of carbon using the NLX method. The atomic number of carbon is 6, which tells us that it has 6 electrons. Following the increasing order of energies of sublevels to fill these electrons, you can see that out of the 6 electrons, the first 2 are filled in the 1s sublevel. The next 2 electrons are filled in 2s sublevel. The remaining 2 electrons are filled in the 2p sublevels. Therefore, the electronic configuration of carbon is 1s2, 2s2, 2p2. Following the orbital diagram method, the first 2 electrons represented by arrows here are placed in 1s orbital represented by a box. On close observation, you will see that the first electron in an orbital is always an electron with a clockwise spin represented by the upward arrow. The second electron in an orbital is the one with an anti-clockwise spin represented by the downward arrow. The next 2 electrons are filled in 2s orbitals in a similar fashion. The remaining 2 electrons occupy the 2p orbitals. While filling this orbital, we need to follow Hund's rule. That is, the p orbitals should be completely filled by single electrons before the pairing of electrons could begin. So, in carbon, the 2 remaining electrons should be placed one each in the orbitals of the 2p sublevel, 2px and 2py orbitals. Let us now write the electronic configuration of phosphorus using the NLX method. The atomic number of phosphorus is 15, so it has 15 electrons. Now, following the increasing order of energies of sublevels to fill these electrons, the first 2 electrons are filled in 1s sublevel, the next 2 electrons are filled in 2s sublevel, the next 6 electrons are filled in 2p sublevel. Among the last 5 electrons, 2 electrons are filled in 3s sublevel, and 3 electrons are filled in 3p sublevel. Therefore, the electronic configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Using the orbital diagram method, 2 electrons fill the orbital 1s, next 2 electrons in 2s, followed by 6 electrons in 2p. The next 2 electrons occupy the 3s orbital, and the last 3 occupy the 3p orbitals. Condensed electronic configuration. Writing of the electronic configuration of elements using the NLX method or the orbital diagram method becomes increasingly complex for elements of higher atomic numbers. For example, the electronic configuration of the element oganesson, which has the highest atomic number of Z equals 118, represented as Og in the periodic table, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6. Can you imagine how the block representation of this electronic configuration would look? It would be very complex indeed. Besides this, we would also need to know the configuration of the outer shell or valence shell to understand complex concepts in chemistry better. In order to simplify this task, we could express the electronic configuration of an element in the condensed form using that of the noble gas nearest to the element in the periodic table. And how do we do this? We simply write the symbol of the nearest noble gas whose atomic number is less than the given element in braces, and then continue writing the electron configuration for the orbital sets that follow. Let us understand this better by taking the electronic configuration of zinc As an example, the atomic number of zinc is 30. Its electronic configuration is written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Argon is the nearest inert gas to zinc, whose atomic number is less than zinc, with the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6. Now, replace this configuration with the chemical symbol Ar of argon in the configuration of zinc. As a result, the electronic configuration of zinc condenses to Ar 4s2 3d10. You must note that to express the condensed configuration of argon, you have to use the noble gas that comes before argon, and that would be neon. So the condensed configuration of argon is written as neon 3s2 3p6. Similarly, the electronic configuration of sodium, Z equals 11, can be written as neon 3s1, and potassium, Z equals 19, can be written as argon 4s1.